Okay, so Arun says things are clear so far. Great. So we proceed then to today's session, which is talking about all the tools that you would, not all of it, some set of tools, and then again in the next class we'll be doing some more set of tools as such. So today we start with the two very important tools of DNS and DHCP, which actually is the backbone of the internet or the IT space. The IT space is. So today's module is going to be understand common infrastructure servers. Okay, so what we try to learn today? We try to understand what is this DNS server. We try to understand what do you mean by the web servers. We try to understand load balancers. We try to understand what is network file sharing. We also try to understand DHCP as well in this, and we're supposed to do the labs for all of this. So let's see how much of time we have to actually spend and do all of these as well. So we start with the theory because these theories are so very important that understanding your DNS and DHCP becomes the most important aspect of this entire space. Generally, otherwise also, and it becomes more critical when you are actually handling your DevOps as such. So DNS. Want to ask if how familiar are you with this concept of DNS, and any experience previously trying to configure this, or trying to learn this particular topic? Or do you have any questions that you want to you want to know prior to even me starting off this? Okay, so a DNS. So what is DNS? Okay, so your domain name system. Now it'll be very difficult, it says, for people to access internet with IP address, as it is difficult to remember. So from a conceptual point of view, he just says that a DNS is only it's just representing a set of IP addresses using your character system. That's all it is, actually. But there is much more than that. Now, how do you start this whole conversation on DNS? Now, how is the world going to be without your DNS? Now, much before even a DNS started, there was this flat files. Now, what were these flat files as such? Now, if you go back, I think your early stages of internet evolution, everybody had a file which I think you're all familiar with, which was this etc host. So what was this etc host file? So etc host file was a file which mapped name to IP addresses. So that means there were maybe a few hundreds of them or few thousands of them. So if somebody had to come to the launch himself into the internet, he would get an IP address from one of the authorities, and then he would make these changes in this etc host file, and then he would share this with the rest of the folks. So this way, all these IP addresses and all these machines which were together were able to communicate with each other by the a name or IP name by the name or by the IP address. So so resolve IP to name, and as we remember name much better than a bunch of them. Perfect. Yes. So that's the whole idea of DNS itself. And okay. So GR says that the whole idea of IP is to for humans it's better we remember characters better than a bunch of numbers. So that's why we have it in a character form than in a number form as such. Now, so how did the DNS actually evolve? So that's what I wanted to come to, and then how the life is with today with DNS as such. So even before probably getting into the concept of DNS, so if two systems needs to talk, we all know that it requires an IP address. So if there is an IP address, two systems can easily talk. So we know that's point one. Now, if two applications need to talk, and that's what actually happens indirectly, we also need to know what is called as a port number. So a combination of an IP address and what is called a port number, which is nothing but a number which identifies an application within that particular machine. So when two machines are trying to connect, we have one machine, so both of them have an IP address, and this so the client machine which wants to talk to the server machine, that particular server machine should have we're trying to talk to that server machine. In that server machine, we're trying to talk to a particular application. Now, because of which that particular application should have some identity in terms of numbers, just like how IP address is. So that is called the port. So every application are identified by what is called as a port number. So that way, each application which needs to communicate outside it via client or via server itself will have its own port number, which is again going to be unique. Now, this combination of IP and port is what we call as socket. So this gives that unique identity. Now, so for example, now from my machine here, I'm able, if I connect to say, if I connect to another server taking an SSH session, and I open this in two different windows. Now, what happens is I'm making a socket connection. Why do you say I'm making a socket connection? Because I'm giving an IP address and giving a port number to connect to that particular server. But you saw. But what I'm trying to say here is I'm trying to make two different connections, two connections from my machine, but to the same server. Now if you look here, if I'm trying to make two connections from my laptop, I need to identify these two connections differently. So now what happens in this case is, just like there is a socket which is nothing but an IP plus port created on the server side, equally there is an IP plus socket created in your client side as well. And this way, what happens is the port on the server side is always fixed, because each app has given a unique port number within that particular server. Whereas in your side, the port number is dynamic because we are making sessions from my laptop, and I said if I'm making 2 sessions, those the port numbers cannot be the same because we need to have a unique path to each of these connections. So so this combination of IP and port is what which creates a socket in our side as well as on the server side, whereas on the client side it's dynamic, and whereas on the server side it's static. The port number is static. So this is how you actually initiate a connection as well. So let me check if there are any. Yeah, we don't have any questions. So this is how we actually get a connection done. Now in this, so how is DNS coming into this particular so earlier when we had less number of systems, we invariably knew our IP addresses, and we knew our IP addresses, and it was very easy to remember your set of machines within your own department. But that's not the case today, right? When there is at this moment, I mean, if you take all the IP addresses of the 32-bit or IPv4, it's all, yeah, we are going to hit kind of 4 billion or so. And whereas if you hit your IPv6, though we haven't seen much use of it, though there's already on the server side and but with the concept of this Internet of Things, we would definitely be seeing how IP6 is going to be used. Now, now I said I initiated a connection using the IP address. Now, how do we initiate a connection with a name but not with an IP address? So, if I had this file in your respective host, I could have initiated this particular connection using the name than an IP address as so we will see how this is going to come in and how this whole architecture actually works out. Okay, so just the pictorial presentation, nothing much that's significant in terms of what it's trying to show, but this is how it would look like in a numerical format than in a character format as such. So just go ahead with this. Okay, so so as I said, DNS stands for domain name servers. It is the foundation of the internet naming system. It eases out remembering host names rather than IP address, which are numbers, and remembering the IP address instead of Google is tougher. So it is just a mapping of IP to names, and I can send an email with the user and the IP address. So I think that's something which it's obvious about. Now, why did the DNS evolve? So now, as I was saying, the DNS got evolved because earlier we just had one file which was etc host, and that had to be shared across multiple people, and we didn't have an option to control who's going to edit that. So if somebody had to come in, anybody would edit and create make changes in that and then give across to everybody. So I'm trying to say, if you take your home if you take your home network, we are not going to create a DNS to connect to each system within your home, right? If you had a couple of systems, you're not going to create a DNS to connect. So we would invariably work directly with an IP address, or if you maximum wanted to have if you wanted to do some mapping, we would just edit this file called etc host, and that should take care of connecting to any of these machines. But if you want to, if you see that, if you want to make a connect each, so my etc host should be the same as your etc host, and if this way you look at scenarios, if you had 1,000 hosts and each one had to connect to each other, then this etc host of all of these individual machines have to be the same, and the 1,001 guy comes and we have to add him. If you want to add him, then we need to make again changes into these etc host file. So you can see the number of changes, and this is just impractical to impractical to maintain, and that's how this DNS got evolved. Now, so let's start with this concept of what is called as root server, a root server as such. Let's try to understand what is this term called TLDs, what is authoritative name server, and what is resolvers means. Now, what is this root name server? Now, we've always typed. So we've. I just want to. I hope my thing is visible. So we've always, typed when you want to type into something. We would always say www.google.com. But what we don't do is we don't put a dot. So there exists a dot actually. So what is this dot? Now this this dot is what we call as the root server. Now what is this root server? Now first I want to tell you there are not many root servers in the world. There are around, I think, 70 odd or so root servers in this world. Now what is a root server? As I was saying, when you create a DNS, so DNS is being created with an inverted tree structure format. When I say inverted tree structure format, so there is a starting point, and then as the branches go, then you will have many trees, just like your file system. So this starting point of the inverted tree structure is actually what we call as the root server. So the point one here is DNS is a inverted tree structure format, and who has a starting point called root server. So when you type this URL called www.google.com, what happens is you are sitting on a side of your telecom network, and then you're trying to get an IP. What are you trying to achieve by typing www.google.com? What we're trying to achieve is we know that there is a server by name www.google.com, but what we do not know is what is its IP address. So now to get this IP address, it does a search. It does a search. So this search is of two types. It's called iterative and recursive. So there are two types of search what it does. Okay. Now when it does the search, so when it tries to do a search, what happens is when you type www.com from your browser, the first server it is going to hit to get the IP address of this machine called google.com is what is called as the root server. So root server is the most important server in the internet of this entire infrastructure, which will guide you to go to where your the Google server is. Okay, now this root server is represented as a dot. So when I type google.com in my web browser, what I did is, though I did not put that dot, the browser puts that dot by itself. So when you type Google on, you directly go into the server called the root server, it's from here we can actually start and find out where your other servers are. So it's www.com, and we have a dot which we did not specify when we're typing in the browser. So what does the root server contain? Now the root server contains pointers to what are called as TLD servers. So what are these TLD servers? TLD servers are the top level domains. So these servers are called as your .com server, .org server, .edu server, or whatever. So whatever you get after the name .com, .edu, etc., .in if it's in India, or whatever .web, you get many of these names today, and there is and what we're going to see in the future is you are also going to create TLDs for bigger organizations. So like you're going to have .microsoft, .ibm, and remember after each, say .ibm, .microsoft, so you also have this dot. Don't forget about the dot. So .com, so the root servers actually contain the pointers to where your TLDs are. So in the TLD, you would have listed where Google is. So in the TLD, you would have listed an IP address of your Google server. So we have moved from your dot. When you type, it goes to the dot server. From the dot server, it goes to the .com server. Now in the .com server, there is a pointer to where the Google's DNS server is. So I hope you are able to get this, though, because I'm not really any questions. So it tells you where your Google's DNS server is. Now what is this DNS server? So DNS server is a server which contains the name to IP mapping or IP to name mapping. Isn't that correct? So once you know where your com is, once you know where your in the com where the pointer is to the Google. So my search now moves from the TLD server to what is called as the authoritative name server. Right? It goes to what is called as the authoritative. So what is this authoritative name server? It is a server which the TLD points to, saying that it contains the IP address of that google.com. And who actually maintains this authoritative name? So it is Google themselves. Now in this architecture, so what we see is there is a hierarchy. There is a root name server, there is a TLD name server, there is what is called an authoritative name server, and each of them are controlled by different individuals, as you see here. right? Now, this was not the case earlier to having DNS. As I said, prior to DNS, there was this flat file called etc host, right? The host file. So host file, anybody could edit, and it was not hierarchy. Now you see here, there is a hierarchy coming in, and because there is a hierarchy coming in, there is an administrative control which is kind of getting into this whole picture. So now you see that, so we have moved from your root, your TLDs, and it's come up to your name server. Now in the name server, you would definitely have you'll definitely have a file which holds that IP for that particular name. Now here it is going to be Google, right? And in that particular file, you will have a name called Google, and Google will have a respective IP address. Now, so where did we all start this from? I'm actually typing all this on my browser, right? So this way, my browser now gets to reach that server, which is google.com, and whose IP address has just been retrieved from this authoritative server. Now, once this whole process is done, the browser gets that IP and he is able to connect directly to the Google server henceforth. So this whole process is what we call as resolution of your IP address. Okay, so I think we'll take a lot of questions. Okay, so Kishore is asking me, so this root server is hosted by Google or internet as such? Okay, now yeah, so now as we discuss this, Kishore, the root server is henceforth going to be owned. It was owned by this ICANN, and it's now going to be owned probably by the UN in the United Nations actually. Otherwise, it is owned by the ICANN, an organization called ICANN. Now, what is the problem right now? All of these are under the control of the US government. So because internet originated in US, right? So every one of this was actually under the control of ICANN, and ICANN was a US body. Now it's going to be a UN body. Okay, and okay. My question: who maintains TLD and root server? So so you know, as I told you, root servers are maintained by your ICANN. Then so TLDs also get into your ICANN as such. Now, as we discussed, you know, I told you there are going to be now newer TLDs which are going to come in. These are for which the bidding is already happened. These TLDs are, as I would say, organization TLDs like .Microsoft, .IBM, .TCA, or .Tata, whatever. So at this moment, all of them are maintained by ICANN, and in a year or so, this control would actually be passed on to a UN body as such. Okay, what does TLD? TLD stands for top level domain. Okay, so are you kind of having a bit of an idea now on how this DNS is actually architecture and things like that? Okay, so this is what I was trying to kind of help you understand. This is called the resolution process as such. So now, is there any doubts that this comes across? Are you getting on this stuff? Okay. Okay, where does the domain name reseller stands in the cycle? Okay, good question. Now, where does the domain? So the domain reseller controls access, or he's got access to these TLDs. Okay, so each of these, so how does it work is, now I said there is .com, right, and there are multiple registrars for this .com. What the registrars do is they have an interface to the TLDs, and when you register there, actually this gets entered into the top level domain through their interface. So that's all they do. They don't maintain anything as such, but there are some registers who actually maintain a complete .com or a .edu. That can also happen as but the registrars, it's only a selling body and nothing more. They don't have anything else in the policy making of how this is all going to work as such. Okay, so any other questions that may be coming in? Okay, so now that we kind of understand how this whole process works, of the what is this root server, what is the TLD server, and what is this authoritative server. So authoritative server is what is under your control, right? Authoritative server is what is under your control. You create and maintain the authoritative server. Now, what is an authoritative? Authoritative server is nothing but a DNS that you as an organization maintain. That's all. But for this to happen, we make entries in the top level servers to say that that you are the DNS server, and you hold this particular set of IP addresses and its corresponding name. So we have, it's not that it's only this name to IP, we also have IP to name. So this whole process, we see that there is individual control of your respective assets. Now, if Google now wants to further transfer powers, they could then create other sub administrative control areas using the authoritative name server. So example, now if you want to create another domain, say we would say like in.google.com. Now in this case, what we are doing is, in the authoritative server of your Google, we are creating another domain. Or so we had the TLDs, top level domains, we had domains, and then what we now call is, we call the subdomain. So subdomain is nothing but another authoritative server that you are creating for you to control the access of your area, of your set of IP addresses. So that is another level of control. So this way, if you see, I can keep creating these trees. I can, in India, I can further then subdivide my domain into, say, Bangalore, and it can go on. But most of the time, yeah, we don't go into such level of hierarchies. We probably stop. Google as an organization is only one domain, and the other domains, even though they exist, they are all managed by the single authoritative server, which is I mean, not given to anybody, but a single guy actually handles within the own organization as such. Okay, so let me see if there is any more questions that are coming in. Yeah. Okay, so Ramdas has, is authoritative server an internal DNS server? Okay, by the term internal DNS server, we again get another confusion. Okay, so let me see if I can answer that as well. Now there are two types of DNS servers based on where they are kind of located. But I mean, do not get confused with what I'm saying. There are two types of servers, but this is just for usage purpose than anything else. So normally we talk about internal DNS server and we talk about external DNS server. So what is this whole thing about internal DNS server and external DNS server? This bifurcation actually comes in because of the firewall. The firewall, when you put in a firewall in your network architecture, the firewall creates what is called as the public side, the private side, and there is something called DMZ side, right? A demilitarized zone. Now, what you ideally do is, you do not want any of your internal servers in the internal side of the firewall ever getting exposed to the external world or the internet world. You create, then in this situation what you want to do is, if you want to set up a DNS which is purely internal to your network or internal to the or in the private side of the firewall, this is sometimes we call as an internal DNS. Now, why internal DNS? This is not an authoritative server from the internet perspective, but it's definitely an authoritative server from your organization perspective. Now, so where does this DMZ come in here? Now, DMZ is the set of area where servers that you want to expose to the external world are maintained. And for the servers of the external world to be maintained, we need to somewhere create a mapping of name to IP, and that is taken care of what we call as a public DNS. When I say public DNS, it is a DNS which sits on the public side of the firewall. It is internet facing. It could be a machine which you have maintained, or it could be most likely a server which is maintained within an ISP, within a provider. Most likely that is this case. But it's not that you can't create your own DNS. You can also create your own DNS as every major organization does, right? But the smaller ones wouldn't. They would use the existing. What do you call the ISP, the service provider provided DNS. So that is where we say there is a kind of a internal DNS and an external DNS. Though both are authoritative, one is just a localized setup only for your own consumption, not facing the public element. Now, yesterday we also talked about this IP address and the classes. We saw there's something class A IP addresses, class B and C and things like that. So when we had these classes of IP addresses, we also kept aside some IP addresses in that whole series of A, B, and C, what are called as private IP addresses. Okay, so like one example of a private is, if you take in the 192 series, 192.168.1. Now, this set of IP addresses will usually not get routed, and they are supposed to be used only within your organization's infrastructure. Yeah, I have another question. Yeah. So that way, all internal DNSs will have internal IP addresses as well, and all external DNSs will have an IP address provided by your provider. So I hope this is kind of clarifying. Let me know if there is any other doubt. Internal DNS is inside your VPN. Kishore is asking this question: is internal DNS inside your VPN? So I'm saying internal DNS is on the private side of your firewall. Internal DNS is on the private side of your firewall as such, and external DNS is on the public side of your firewall. And DMZ is where your organization exposes your servers, which are supposed to be facing the internet. So that's how you organize, and it's the firewall which actually creates this differentiation between an internal DNS and an external DNS, and things like that. Okay, so I hope you are kind of able to understand this a little better. Any other questions that okay. Okay, so GR has a question. Does a firewall software does this internal external logic? No, firewall does not do an internal external logic, but I mean, as you ask this question to me, I can create a DNS server with internal facing set of authoritative rules and external set of facing authoritative rules. I have an option to do this in my DNS, but invariably this is not done. This is not done. You have a separate DNS which is on the external side and a separate DNS on the internal side. Now, where the question, see, where this whole problem arises is in the way we do resolution, right? If it's an internal server and you're sitting in the external and you're sitting from your home and you have to go through the internet, you can't do any resolution of those IP addresses. Internal DNS server can only do a resolution within the boundaries of your corporate environment. And why do you want to, okay, now the next question arises, why do you want to even set up an internal DNS server? I could have actually used etc host file as well, right? Most easily, yes, we could have done that. Just using an etc host, we could have done the resolution. But why we do set up, why do we today, most of the standard application expects you to have a DNS server. And it is also easier to maintain as such. Okay, so the answer to that is a firewall does not have any logic which creates internal or external. It's just positioning of the DNS server. It is just the positioning of the DNS server which creates this isolation, and the entries that you make in your TLDs. So what the TLDs hold is what the external world sees. It cannot visualize what is there in the internal world as such. So okay, so by now you understand what is resolution. Okay, okay, so there is something called caching as well. What is caching? So every time you look for you type google.com, I don't want to keep searching, right? Every time I do not want to go to the .server, come to the TLDs, come to the authoritative server, and then tell you that yeah, this is the IP. You know the number of milliseconds or seconds it may take to do this complete process. So what they do is, what your DNS or your client-side DNS, which is also called as resolvers, do is they cache all the IP addresses that you have, resolved, and he maintains his cache until such a time that I mean, and it can't keep forever. So there's always a expiry on these caches. So it could be resolver based, or it could be even server based. DNS server side time to live, what is called as a time to live, which specifies how long this particular record should be valid. We'll come into that a little later. But understand, basic thing, we do caching because we just don't want to be resolving every time, and resolving creates a lot of latency. Okay, so we understand now resolving. We understand what is root your root name servers. You understand your TLDs and how this whole IP addresses got. We also understand. We also indirectly learned of the concept of what is internal DNS. Though such a thing does not exist in terms of a concept, but it's a introduction. It's been introduced because of the firewall, which actually creates that logical isolation. Okay, so this is the same process which I was talking of, resolving. Okay, so this question asks, is the domain registrars? So domain registrars only is an administrative interface to your TLDs, nothing more. But some registrars can also be maintaining a TLD. So in that case, what happens when you're registering? You're actually registering directly into their servers as such. Okay, so that's all. Their part is in this. But when you sometimes when you register, you feel like that there is another bigger authority and stuff. But the registrars do not have power on the DNS. Understand one thing: if the root servers, which I said, I think it's around 60, 70 now. If the root servers go down, then your entire internet is collapsed. Okay, and so somebody would have to actually really maintain the root server up and running, and that's why you have to. And now the other problem is we do not, like if you take India, we do not have a root server here, right? So any of our queries directly go to the root server, which is outside the country. Now many countries have it within themselves, so that is another way of going about to help in your resolution going a little faster than things like that. Okay. Okay. So as I said, eventually the entire lookup is to get the IP address of the server that you want to take a look. Now, do not feel that the whole resolution is only to get the IP address of the web server. Need not be. We are also looking at the IP address of a mails of an email server, an IP address of a FTP server, or any servers that is actually exposed to the internet and whose IP and name is kept in a public DNS. So it could be for that purpose alone and nothing more than that. Okay, so Kishore has a question. Okay, let me talk to Kishore. Hi, Kishore.
Hi.
Hi. Yeah. If you could just repeat the question for everybody. Yeah.
Yeah. So this caching you said, right? So the caching occurs. So there will be a server called cache server, for example, something like that.
No. See. Okay. If you actually see, there are different types of DNS servers also. you could have, we just talked about authoritative, so you would have non-authoritative DNS servers, cached DNS servers, and various other kinds of DNS servers, though each organization implements in the way they like. Now, here the caching, what I'm talking of, is to avoid the resolution.
Okay.
See this whole process, right? Let me just come back. Okay, so let me. Okay, when a person searches for some address in the browser, say www.com, and I told you that the dot is missing here. So the dot is the root for all the address that stores, and yeah, it goes into your root server. Now, when the request server is first, what he does is, when he does that www, it searches whether any previous resolutions have occurred. If it is, then he
correct. I got it. So when you say when it searches, so that search methodology or search engine or whatever, where is it? It is there is a separate provision for it for cache server. So my question was, for example, is there a difference in caching if between my organization PC and my home PC?
No. Okay. So where does the caching happen? Is it is happening in your local. So there is something called resolver. Okay.
It's happening in my local machine wherever I'm sitting. Is it?
Yes. So the resolver means it is the client side DNS. So where is your client? Your client is the client DNS server is the server side. The DNS client is your own desktop.
Yeah.
Okay, it's your own desktop. Now, how do you help? See, when you start something, you always set. Now, we tend to use this pretty often. So now, what happens here is, if you can see you're able to see my terminal, right?
Yeah.
So you always have to set what is your DNS server. Now, here I have set the DNS server pointing to, today everybody tends to use this. It is pointing to my, to the Google's DNS. 888 is a Google's DNS. So ideally what I could have done, I should have done is, now you can see an IP address here.
Yeah.
Okay. Now that is my service provider's IP address. Okay. Now, so what happens here is when I'm typing www.com, it goes and hits into this service provider's IP address. Ideally, I mean, it should have go and hit there, right?
Right.
And this guy's responsibility to get that IP address of that server which we are looking at. Okay.
Correct.
Once it gets it, you will actually put this in your. It is in the cache of your system.
Okay.
So that's what is cache. So next time I'm going to Google, I will only look in my local cache. I will not get into the resolution mode at all.
Yeah. I got it.
You got this? Okay.
Yeah. Thank you.
Anything else?
No, that's it. I mean, caching, as I was knowing, it happens in the local PC itself, but just wanted to confirm that.
Oh, okay. Yeah, it happens. Yeah, it happens in the local PC. Yes. Okay. So having gone through this and understanding the whole local resolution, okay. So this is what I was kind of talking of on the history. So ARPA. So the era of ARPANET was through this concept of host text file, right? So if you see. Every system comes with a host file. So this used to be there in every server as well. So as you would have noticed, the host text file was a big nightmare when we have to maintain, because anybody could go and change it, and then you lose it. You could so I mean, today's world is just impossible. Anybody can go and change, and you would lose your IP to name mapping, and because you need to share, there won't be little consistency. Of course, there are other ways to manage it, but you won't have an administrative control as such. So if you keep a track, now if you want to, as I said, in IPv4, we can have at least around 4+ billion of IP addresses. Now, if you want your machine to talk to all the 4 billion IP addresses, you need to have a text file which contains 4 billion lines, right? And this is something which is impractical to you. And that's how this whole DNS got evolved as a hierarchical mode of maintenance, so that you only maintain what is yours and do not worry about other guys, right? And these are developed by these sets of people: Douglas, Terry, Painter, and David, and Samyanzo. Basically, the product was called as a bind. The DNS server or the DNS application is called as bind. Okay, so this is how the whole DNS tree structure looks like. Okay, so there is root. So now this is the representation for the root, and these are all your TLDs as such. And there is one particular TLD called ARPA. We'll talk about that a little later, which is one very important aspect there. So the comms will contain all that, your Yahoos and Googles and whatever that may be. Okay. So now, DNS records. Okay. Now let's see how we learn to configure a DNS. Now that's so that's the next part of it. Yeah? Now, in Unix, whatever the software you get for DNS is nothing but what is called as bind. Mind you, this is not the only software. There are other software as well, which are created for DNS. So, but the most popular being the bind. Huh? Now, configuration of DNS is basically 5 files. It's just 5 different files and nothing more. Okay, so one is called your named.conf, which is in the etc directory, and then there are other 4 files which are in the where named directory. So of the 4, 2 are mandatory and 2 are optional. So what are these 4 files? One is called the forward zone file, one is called the reverse zone file, and the other one is called your loopback, and the final one is a file which contains the set of your root servers and nothing more than that. Okay, so these are the 5 files which actually creates your entire DNS, and there is a process which handles the whole thing. Now, DNS records. So what is this DNS record mean? So DNS records are primarily mapping files that tells DNS server about which IP address each domain is associated with, and how requests can be handled that is sent to each domain. So different strings of letters are used as commands that decide the actions of the DNS server, and these commands are called your DNS syntax. Okay. Now let me probably okay. So are you getting what a DNS record could be? Maybe I should fire up my server here. Just give me a minute. Okay, so Sandeep has a question here. Can you add PTR records? Okay, so let me ask him what he means by this. Okay, see, probably I did not start on the, anyway, now since you've asked this question, let me get back a little into that reverse side of it. Okay, so we all know that once you have given your name, you can get the IP address. But there are some applications which wants to also do what is called as reverse lookup. When I say reverse, here is the way. Let me show you probably a demo that could. So I do lookup. Okay, so I could do this, and it gives me the list of IP addresses from your these are IP addresses of their servers as such. Now we could also do this. Okay, so now what we are doing here is we are getting the name from the IP address that you know. So this is called what is called as your reverse lookup. Okay. So coming back into this, so we always saw there is a root server, there is a .com server, edu server from which you get your IP addresses, right? But there is one server which actually helps you to do the reverse. So now when I give an IP address, right, where does the first hit should go to? See, I gave you, what did I do here? I gave, now NS lookup, I'm sure you know NS lookup, right?
Right.
Yeah. So when I gave NS lookup, NS lookup is nothing but a DNS client. When I did an NS lookup for www.google.com, this guy did a complete resolution of my of google.com, and it gave me a set of IP addresses. So when I'm doing the reverse, it is again doing a resolution, correct?
Yes.
It is again doing a resolution. There is no change in the way. So resolution means you look into the local cache, then it will go into my primary DNS, and then he will do an iterative lookup, and then he will come back with a name. So where does this guy go for a reverse lookup? And this is where he comes to. Actually, he hits the root server, he comes to ARPA. ARPA is a top level domain which actually holds all the IP addresses that you are aware of. Okay, so now when you did a NS lookup, it goes to here, it goes to ARPA, and then in ADDR. In ADDR is the database of all known IP addresses that we have, which are in service in your internet world. Okay, so now, so this is something which happens in the reverse lookup architecture. So just like your, we had a forward lookup, we also have a reverse lookup, right? And I talked about there are 5 files. Now, of the 5 files, one file gives you the forward lookup, the second file gives you the reverse lookup. So that's what I wanted to actually show. So we will look at all these a little later as a part of our lab. So this is a file in which I have added my reverse lookup. Okay, and Texla.com is we'll talk about zones and all, and this is a file in which I have created my forward lookup. Does this answer the question what you are looking at? Is this the query what you're looking at? Sorry. Okay, so so now you should be able to see this PTR records, right?
Right.
Yeah. So is this the question that you wanted to ask?
Yes. You just opened one more file that I just seen. I'm not sure what it is. It
Okay.
looks very interesting.
There are two files which I have created here. Okay. One is called your forward zone file, and the other one is called your reverse zone file. So what is this forward zone file? Forward zone file is the file which you do IP to name. Okay. So this does your name to IP. I'm sorry. It does your name to IP address. So this is what your authoritative servers are. So this is what your TLDs are. All your TLDs are this. Okay, so TLDs are all forward zone files, whereas your ARPA is the only domain, only TLD which does the reverse zone.
Yes.
Okay, so does that answer your query?
Yes, that answers my query. I have one more doubt. I just asked. Here, the software that you are using is can be installed on Ubuntu.
Which software thing?
DNS server.
Yes, you can install that either on an Ubuntu or a Red Hat or any of these operating systems.
Right, using apt-get I can install that.
You can use an apt-get and try to install that. That's right, yeah.
Okay. One more question that I have. Sorry for again asking that.
No problem. I mean, sorry. Don't worry. Don't feel sorry about it. You're supposed to ask anything, and I'm supposed to answer all of them.
Okay. So just wanted to know about that. If you can install this, if I need to install this DNS name server, do I get some utility just like firewall? I have utility called UFW, right? So to easily add entries in the firewall, do I have any utility here similar like UFW? So that my IP tables is a very rough way to do the and put the entry on the firewalls in Linux. I just wanted
You're talking of for the DNS as such.
Yes.
You know what? So DNS. See, there are front-end tools to actually add entries, but the DNS needs to be configured from scratch.
Okay.
Okay. So that means I have to install this, configure. Though and we're going to do this actually as a part of the labs, either today or tomorrow. Today or the next class. We will have to we will have to go through this whole process of installation and configuration. Only then your DNS is going to be up. Otherwise, it's difficult to get this going.
Okay, cool.
Okay, so we will do that. We will definitely be doing one lab for this.
Okay. Thank you.
Okay. Okay, so hopefully all have settled. We can just we can start this again. Any doubts until now? Is there any other questions that you think that we need to discuss? Because DNS, I mean, you know, always a DNS session will have a lot of queries in terms of how it is, you know, implemented and the general theory itself. Okay, so if it is just raise your hand and I will get on to the questions quickly. So I was talking of DNS records. Okay, so what is a DNS record? Now let me, okay, I think, let me show you that. So this single entry, so if I open a forward zone file, so I'm opening a file. Now this individual entry or this individual entry is called a record. Okay, so an individual entry is called a record. Now, how is it a little different compared to the other records? You can see a lot of names like this: A, AAA, CNAME, MX, PTR, NS, SOA, servers, and text. Okay, so let's understand what these mean. So I told you there are 5 files. Now the file which is often updated is called your forward zone file and reverse zone file. What is a forward zone file? A forward zone file contains name to IP, and reverse zone contains IP to name. But when you're creating these records, we have to specify what kind of record it is. Okay, so when I say it's an A record, if you can just see this here again. When I say it's an A record, what that means is it's a IP to name resolution. Okay, it's an IP to name resolution. Then when I say it is PTR, okay, so what it means is let me just open that. What it means is it's a IP to name resolution. So that's the meaning of it. Okay. Now that way we have many other records. So let's see each one of them. What does NS mean? When I say NS, we are telling this particular server, this particular server is your domain server or your authoritative name server. Name server means it is an authoritative server in which the records of your hosts are kept, and they are authoritative. That means they control that entire records. Okay. So as we see that there's an A record, there's a PTR record, and there is an NS. Now you also see some SOA. Okay, start of authority. It stores important information like a timestamp and changes needs to be made in the domain, etc. Now, if you see here, these are kind of your serial number, how often you should refresh, and if there are so DNS servers also is designed in terms of I mean, like yesterday I talked about 3 terms for availability, right? The fault tolerance, high availability, and DR. So this has also been designed for high availability, and there is a secondary DNS server as such, which can handle if the primary DNS goes down, and that's how it's always architected. And then you have certain parameters that you can mention here about all those kind of things. Okay, so that's your start of authority. So I told you I told you PTRNS, start of authority. Now, what is this MX? I don't have an MX here, but what MX means is that particular IP points to a mail server. So if you want a mail to be delivered, and a mail always works with a DNS actually, you need to create an MX record. Just like you create an A here, you give a name as MX. MX means pointing to my mail server. Okay. Then, okay. So now this is a new class. I personally haven't used this. Okay, but in future, when we create a DNS for IPv6. And when I say IPv6, a DNS record for IPv6, we will have these 4 A's. Okay, I haven't used this much, or rather, I would say I have never used it because I don't create a IP record with AAA. But this is how this would probably handle. And as we know, there is this concept of Internet of Things coming in, and when that steps in, I feel there is a good chance we may have lot of entries for IPv6 as such. Okay, and finally there are two other entries. Text just gives you some text information that can be added, and a service, it tells you that I should be using a DNS. I should be using whether TCP or I should be using UDP to handle my request. Okay, any questions that is arising here? Okay, so it looks like all seem to be okay, and I'll go ahead. Okay, so we discussed quite heavily on the resolver. So what is a resolver? DNS, the client section of the DNS, and where does that sit? It's like in your laptop or wherever whoever wants to do a resolution. So it could be your email client, or any server which wants to use DNS services will have to embed DNS client in their software for name resolution. Okay, so the client section of DNS is called resolver. Once they start at the client side, they contact the first DNS server specified in the etc resolve.conf, which I showed you, right? It initiates and sequences the queries that translate the domain name to an IP address. That's the whole, and it contains this library called resolve.co. And as I said, there are 2 types of resolutions. One is called recursive, one is called iterative. So what happens from in a recursive? In recursive query, DNS server will fully answer the query by querying other DNS servers as required. DNS servers are not required to support a recursive query. Now, what this means is all requests which comes from the client are all recursive. Right, and I think JR asked this question: how do I forward? How does an internal DNS talk to the external? So you see that there is an internal DNS talking to an external DNS. So that means it's a DNS to DNS discussion, right? And if it's a DNS to DNS discussion, it's primarily an iterative query. So what is the difference between an iterative and a recursive? Iterative need not provide full result. Okay, it can give a partial result, or it can give anything that it knows, but it's not in its job to give him the absolute right answer as such. Okay, so any questions coming? Okay, so this is a pictorial representation of how it would all of the whole resolution happens. Your web client, mail client, the DNS resolve looks in local cache. If not, connects to your DNS server. It could be a ISP or your local, and then the recursive search. The whole thing starts. So I guess now this is pretty much clear to all, I suppose. So caching the queried records are cached for future use according to what is called as TTL, time to live. The caching can be at different levels, like local caching and caching at edge routers, caching at ISP. But remember, if all these guys have to cache, they have to be a DNS server, otherwise they cannot really cache it. Okay, so caching improves your resolution time, reduces the load on the DNS, and it basically improves your query itself. So ideally, it's all the caching actually happens at your client side, but I can create some caching service. But mind you, this is not general caching. This is DNS caching. So I have to create a DNS caching environment to cache it. It can't be a web caching or general other caching that you may find. You can create a DNS cache server to cache in all it. And this happens many times in a bigger organization as well. Okay, so as I told you, DNS being a very, very important application, or rather the first service, even before a server, even before any other service starts, is your DNS services. Okay, so if you had a chance to set up your DNS, if you chance set up your data center, once your data center is up, your rack is up, your power network, all of them are up, the first service you're going to start is your DNS. Even the first server that you're going to install in your data center is going to be your DNS. Without this, nothing starts. That is your first server. You need to, so any design should start from that. You would first install your DNS server, only then other services start. So DNS being a very important thing, it has been designed in a master-slave scenario, which, as I said, is for high availability. The server which is the master for a zone and has the authority for it. Secondary pulls data from the master server and can be many numbers and spread across the globe. Okay, so if you want to have a faster resolution, say like, so if let's say Microsoft holds this DNS server in the US office, and users or the corporate users in India, the Microsoft corporate users in India wouldn't have to do a resolution going up to the Microsoft server there. I can put a DNS server in India, cache it, and I can use that as the authoritative server for me to go out, come in, whatever that means. Okay, now I talked about the 5 files. What I did not show you is the named.conf. Let's have a look at that. What does it contain? Okay, so I think it's Ramdas who has that question. Yeah, so I think yes, Ramdas asked this question, right? He asked, what does this registrars play? Actually, this is the role of the registrar. Now you want to create your domain, right? See, now you want to create whatever, say, like anything. So Sandeep says he wants to create a zone called sandeep.com or sandeep.u. So you need to define this in some place. That file or that master file is called named.conf. And when you go to a registrar to register, this is what happens in the backend. It creates a zone called as per the domain. So that means if you have created a zone called texture.com, it creates, it goes and creates this file, and it says it is the zone is a master zone, and it creates its forward zone file. So we know the forward zone file is the file which does the name to IP resolution, and this particular file is also, I mean, so JR asked, where do you, if I want to forward my queries to the from the internal to the, where do you make that entry? In the options part of this. So this is the master configuration file for your DNS. You can, I mean, this is a very simple one. It tells you where your zone files are kept. I can do, I will tell my, which is my, if what is my higher level DNS server, I make that entry, my logs. Then I can actually even do encryption and various other things also with this particular file. I'll create all my zones. I'll create my reverse file. So if I want to create one more new domain, I just, you know, here I just cut and copy this and make changes. But if it's, you want to do this on the internet side, you go to a registrar and then say, I'm creating this particular zone. Okay, so this is what happens in the backend. Now, the other thing which I want to tell you is, yeah, we are all working. I'm all working here in files, but in a look at your root DNS server or TLDs. They are not basically files. They will be some backend databases in which you actually store. So when you go to your registrar and register, it's actually not going to a file. It's actually going to a database, because a flat file will crash with the number of entries. I told you IP4 can have 4 billion plus IP addresses, right? So that will crash. So that's why we don't create anything. But all our learning, or all the files which you set up in an enterprise, they're all flat files. But registrars and other big, like a Yahoo or a Google or a LinkedIn, do not maintain a text file. They actually create a database to store their data. Okay. I think. Okay. Okay. So, any questions? Okay. So we would not do the demo right away, but I finish up all the theory, and then we will get into the demo, which I'll show you once, and then you could also repeat it. Okay. Probably I do not know whether we may have time to finish all the demo as well, because I have a couple more other theories to do, and I finish that, and then we will separately do all the demos as such. So what is a DNS server? So you can, so do you know the answer to this? Is it a database for storing users? Is it domain servers? Is it used for authentication? Okay, so the answer is it's a domain naming service. Then can I have a DNS record without a trailing dot? Yes, we can always have. Oh, no, only the records which specify the IP address. Okay, so what is the answer? Only the record which specify the IP address. And okay, so understanding your the DNS on the internet. Now, you know, this is something which has become very popular. Right. So what is this your DNS on the internet? Now today there are organizations which have come up to give you free service for hosting your records. Mind you, when I say free, you still need to register. Without registering, you cannot get your domain. But you can register in one place. Now, this is where a lot of people get confused. Okay, I can go register in some network solution, but my DNS records can be maintained elsewhere. What you do is, in that particular registrar, I will put a pointer saying that my DNS records are located elsewhere, right? I will give the DNS server's name elsewhere, and that is how he is able to move away. So that's how you can have a registrar who's different, and your DNS records which are going to be maintained in a different place. And today Google team one of the set of guys who can help you do this stuff. Okay, you have any questions on this? Okay, now geolocation. So let's understand this. Geolocation is the identification of real-world geographic location of objects such as source of radar, mobile, or whatever. It is a technique in which users from different parts of the world get into different servers using the magic on the internet. So what is this magic? The placement of DNS servers across different locations using any cast. Now the return address is according to the subnet from where the request came. Okay, so let's understand this stuff as such. It's pretty interesting. Now, yesterday, I don't know whether you recollect, I used a word called CDN, Content Directory Networks. Okay, so what are these CDNs? And I told you, imagine I want to host my application. I want to host my website, okay? So this particular website is hosted in, say, US, which was earlier, this is what we used to all do, because most of the servers were located there. This website is hosted in US. Now, any user who is going to sit in India will have to travel all the way to US to get the request, right? To get that query, right? To get that particular website, we need to go right up to the US and pull the request down. Now, imagine a situation, if I had kept a copy of this website in India, and the user located in India, when you're querying, we will tell him, you please don't go to US server, we have a copy of it kept in India. Okay, now this is what is called as geolocation based DNS resolution using this process called Anycast. Okay, so Anycast is a networking technique where similar IP address advertised from multiple locations. When the network decides which location to route a user request to based on routing protocol cost, that is the distance, okay, and possibly the health of the server. Now imagine the server is located in India, but the Anycast request, which is actually configured not in any of your DNS, it's a part of your router, keeps a track saying that there is a problem with this server, so you please don't go to the India server, go back to your US server. So it does that in two ways. One is through your cost, the distance, and the other one is through your health checks. Okay, so what does Anycast do? Anycast, using your subnet, your IP address range, where you come from, will redirect you to the closest server for browsing. Okay, so when you do google.com, it will not go to the Google server in US. It will come to the closest area of your Google. Most likely that could be the Singapore or Hong Kong, wherever the Google data centers are. So this is called Anycast way of handling, and though this is not configured in any DNS, but it is kept as a part of your router configuration, and we can't do much about it. It's a prerogative of the network engineers who handle this Anycast, but we understand that there is a concept called Anycast. Okay, so this is how that the entire geolocation things are handled. But of course, this is too much of a complexity in terms of networking. Even I am not so very clear on how the entire routing handles, because it's part of the network engineering who handles this whole stuff. But in essence, this is what it's all about. Okay, so that much on your DNS. So now we get into the other server, which is your web, the other of the infrastructure component, which is your web server. And I'm sure many of you already understand this, but let's go through this stuff again. So web server, everybody knows, is a server which serves requests using HTTP protocol. It can be the entire server or the software running on it. Okay, so the primary function of web server is to store and process and deliver web pages. Okay, we all know there is some features like virtual hosting, large file support, bandwidth throttling, server-side scripting. I mean, are all aware of these concepts, or how is it? Okay, so what is if so let me probably explain them. So what is virtual hosting? Now, virtual hosting means within a single web server, I can host multiple domains. Right? Within a single server, we can host multiple domains. So that means I will have a single Apache server running, but that would be hosting multiple domains. One may be a yahoo.com, or it could be a google.com, and it could be an msn.com. So that is virtual hosting. And all the service providers actually do service hosting because otherwise we may have to have multiple instances of web servers and multiple network cards and stuff. And in virtual hosting, I could do a virtual hosting with a single IP address pointing to multiple domain servers. I could do that. Okay, and which is a little confusing the way it works. We could also have multiple IP addresses pointing to sorry, not multiple, I say, or one-to-one mapping of your IP address and your domain name. So each domain will have its individual IP address. So that way also we can do. Okay. Then this large file supporting. Okay. So today your web servers are not just hosting your web pages. It can kind of today hold, you know that, right? Yeah, I can put a complete ISO image of my server in the web server and then source it from that. So you could do that. Then bandwidth throttling. So what is bandwidth throttling? We could control the kind of limit, or when I say the limit, the speed through which a service is being done. We could do that actually. I mean, of course, we're not going to use that for a web server for that, but there is a feature. There are other ways to get that done. And server-side scripting. So what is server-side scripting? When I say server-side scripting, that means integrating your Apache to host application designed with different programming languages. So like PHP, like Python, but Ruby, etc. Okay, so this is what you mean by server-side scripting as such. Okay. Any questions with this? Okay, so what is this HTTP protocol? Okay, so HTTP stands for Hypertext Protocol. It is used for, it is the underlying protocol used by World Wide Web. It defines how messages are modified and transferred what action web servers and browser should take in response to different command, and your entry, you enter a URL in the browser and HTTP command is sent across your web server to fetch and transmit the web pages. Okay, so let's see these. What does this protocol mean? So this particular protocol has a lot of commands. Okay, like I'm sure you might have heard of this. Your get command, your post command, delete. There are various kind of such commands. So what you do is, when you say www. Some google.com or whatever it is, in the back end you are actually sending a protocol like this. Okay, you're sending a protocol like this. What you're saying is, get me that file. Get me that file. The file name is it's in this path, and yeah. And its name is file.html, and please use protocol 1.1. This is what happens when you type, say, www.google.com or not. Okay, so get is to get all your web pages. So this way, when I'm browsing, it's actually we are using a lot of these get, but it can also be used for other purpose. Now, imagine a situation where you're going to, say, doing a registration, say booking a ticket or whatever. In this case, what we're trying to do is we are sending some data which we have typed in our web page to the web server, right? And what happens there is this web server in turn captures all this data, and then it calls the respective language in which it is processed, okay, and it does the processing. It could be a submit or a retrieval or whatever that may be, and it comes back into your page. So for that, we use this protocol called, okay, I think it's not mentioned here. We use a protocol called post. So like that, HTTP has multiple protocols, get, post, what those things mean. Okay, so are you getting this? Any questions here? Okay, so this is how a HTTP program or a web server actually works. Then, if you have noticed, this HTTP server has a lot of these. You get this, numbers like 200 or 400, which is pretty much common. Okay, and sometimes you hear this fine. So if it's errors on your on internet are quite frustrating, especially when you do not know the difference between them. So these errors are called HTTP status codes. Okay, are response codes given by the web server, and these help in identify the cause of the problem. So what are these? It's important to know these codes, and it helps you to debug this. These information codes, 100 means it is continue. That means it's just an informational code. If it's 200, that means the web page has been downloaded and there's no problem. If it's 300, that means that URL does not exist and it's redirecting you to another place. If it's 400, that means that URL does not exist. And if it is 500, that means I think if you've been developing any applications, you would have noticed when you notice that the web. So when you are kind of doing a registration, you have to call some programming language. If the programming language, in a simple case, may not have an execute permission, then you will also get such errors like this. Okay, so this is where these errors are, and they are these are the different types, and that's how you know your status of your web as such. Okay, now there are actually so many web servers that are in the market. So many of them. The most popular is Apache, and today the second most popular web server is what is called as Nginx. Okay, I'm sure you might have heard of this. It's becoming the second most popular web server in the market, okay, followed by your Microsoft's IIS, Internet Information Server, and a host of other servers that are there. But Apache continues to be the most important and the most powerful. Okay, the most important and the most powerful, and Nginx kind of coming up to be the next most important. Now, the configuration of your Apache. Now, that's a very simple thing. You have to install your web server. Okay, that is through either it could be, if it's CentOS, it's going to be HTTPD installation. Then it just has a single configuration file. Okay, so it just has a single configuration file, which is called your http.conf, and the directory where all your objects are kept. When I say object, this is your images, your HTML files, or your or any other files that you want to serve through the web are kept in this particular path. Okay, so this is how this is configured as it. And then of course we're going to do the labs of all of these things. Any questions? Okay. Then once you have configured it, there is you start your service. The service is called HTTPD. Okay, and if you make some changes in your HTTP conifer, and if you want to immediately take effect, we do this command called reload. Okay, so it will be example like adding a new domain into your configuration file. So we add this and then we reload the whole stuff. Okay. Okay, so if you look at your http.conf, you will have a lot of these configuration setups, and some of all these, like root server. This specifies where your documents are going to be located, and in this case, your var whtml is your root server. Okay. Then keep alive. Whether server allows one or more requests per connection. Okay, I'm not sure how many of you all know this. When I do a browsing through any of the browser, it is not a single connection actually. There can be multiple connections. So what happens in multiple connections means that I'll be opening two different sockets to connect to this particular server, which actually just helps in improving your speed and things like that. Now, keep alive is another situation where I do not want to creating socket every time I try to connect to a web server, and anytime I also connect to a web server, I want to use that existing connection to actually send the request. Else what happens is, if I don't say keep alive, I'll be keep opening up and be sending my connections through new socket every time I want to process something. So this helps in kind of doing a single pipeline is always opened up to do it multiplexes. Basically, it multiplexes. Start servers sets how many server process you have to start. So when an Apache starts, there is a server which starts up. Okay, so what is this is so this server handles each of your client requests. But if there is only one server, and then I can only start, then only one guy can actually connect to it. So, but what he does is he starts child process. So max requests, the total number of requests each child server process serves before the child dies. Okay, so that's your child process, and max client sets the total number of server process that can run at one time. So what that means is when somebody says that I'm able to process 1,000 requests per second, it means that the server is designed to handle 1,000 clients simultaneously, and that's what the max time. Okay, and then you have the min spare and max spare. If number of servers waiting for a request is less than min server, it creates some, and if the number of servers waiting for request is more than max, it kills some. So what this does is, see, I'll tell you why Nginx has become so popular is every time I have to connect to a server, I will have to spawn a socket. Okay, I will have to spawn a socket. The spawning of the socket is a very expensive process within your server, and it takes definitely some milliseconds for this to happen. Now, if there are thousands of them, it's very difficult for your server to handle, and it starts going slow. Okay, so that is why sometimes you instead of waiting for some client to come, you keep some minimum servers ready, and if you feel that it is actually going, it's not going only going down, I actually kill this. So that is why this min and max servers are. Okay, any questions? Okay, so yeah, as I said, it's the most widely used. It's an open source. Rather, every flavor of Unix actually has its own. So you might have heard sometimes there's an IBM HTTP server, Oracle HTTP server. Now they are all Apache servers rebranded by these organizations. Basically, they're using just Apache as the server to do the services. Okay, so as a part of so the whole idea of having a web server is definitely to do some kind of content serving. Now, for this content serving to happen, we have to integrate this to our DNS. Otherwise, we'll have a problem, right? That's what we have seen. Now, how the web server itself is placed in an organization depends on how do you design a firewall. And as always, as I said, firewall has three legs: your public side, your private side, and what is called as the DMZ, or the demilitarized zone kind of a site. Okay, so all your web servers or any server that needs to be internet facing are kept in your public side, in your DMZ side, and all the DNSs and all the DNS entries which needs to talk to these servers are kept in the public DNS, not in the internal DNS. Okay, so that you need to understand. If you keep this in the internal DNS, then the public who is going to come will never find this server. So you understand, I'm sure you understand why it has to be kept in the internal. Now you also get a confusion here. You have an Apache server which is serving the internet, right? But what about the internal users? So what they do is, now to handle such a kind of a scenario, internal DNS will have to create its own entry to actually point to this part. So normally they don't do a forwarding. They will create another pointer to this to the web server so that it could handle both. When you are in the DMZ zone, you could move from internal to DMZ, but not to the external side, and the external could come from outside to the DMZ. So DMZ is like a quarantine, it's a bit of a quarantine. It's a controlled area where people from both places could come and interact. Yeah, and you know it, and this is to keep all other unwanted users away. That's the whole idea of this particular setup, right? Apache can run in two modes: pre-forked and worker multiprocessor mode. Pre-forked mode creates one thread per process, each of which handles one user request. In pre-fork mode, process handles one connection only. This process is thread safe. Whereas in worker mode, creates new process too, but each has more than one thread, and each of which handles one request per user. In worker mode, processor handles more than one connection. Okay, see, this is an architectural design of your application. Okay, so there are two ways for your application to be designed. Okay, now let's take a telephone example. Try to answer this particular solution. Okay, now if I'm making an individual call, I can't talk to anybody, neither the person on the other side can talk to anybody, isn't it? It's just a one-to-one connection, and we can't just get out of that loop, right? But imagine if you're doing a conference. We have simultaneously many people handling, many people coming in and talking, and then it's a completely two-way, right? It's a two-way talking, but it's a conference. There are multiple guys who are getting connected there. So Apache server has also been designed in there. When I say pre-forked, it is one-to-one. And when I say multi-worker mode, that means one socket can handle multiple connections. Okay, so what is the advantage? See, there was this challenge called C10K, C10K. Now, this particular challenge, I probably do not know who might have, who actually started off. Of course, you can see it on the net. Is the challenge was, can I use my existing web server, and can I have 10,000 simultaneous connections? I'm talking of not the present servers, the earlier servers. I think these were the times when you had that 1 gig processor. Can it handle 10,000 connections? Apache server could not, because to handle such a kind of a connection, you need to have very fast CPUs and equally good amount of memory. Okay, only then you could handle. Now, so they realized that in a pre-forked environment, this would not happen. So they designed this architecture of worker mode way of processing, in which if I have 10,000 connections, right, I would not open 10,000 sockets. I will, in your worker mode, I won't open 10,000. I will just open up some 10-20 of them, and these 10-20 can then handle actually 10,000 people. So that's the architectural difference. Just like how your the analogy is basically the way group chats and group conference calls work. That is the whole, where there is a way of slicing and weighting and dicing. I mean, a lot of things in terms of how that multiplexing happens there. It's a time division there. Each, though it appears that everybody is together, there is definitely a serial way of connection which is happening, but we do, because of the speed of the process, we are not able to feel that. You feel all of them are happening together simultaneously. Okay. Are you getting this? Any questions that are arising in your mind? Okay. So, yeah, the limiting factor, as we all know, has been the memory, which has always been a problem for all the internet-facing web server, the servers, right? And the potential to deadlock threads that are contending for the same CPU and memory. So, if a thread is stopped, the user waits for the web page to appear until the browser makes it free. So it can send back the page. If a thread is deadlocked, it does not know how to restart, thus remaining stuck. Okay, so when does a deadlock happen? Deadlocks happen when there are too many threads. If there are too many threads, I mean, we know, right? When there are too many people, there is a general chaos. If they are trying to seek an attention of some particular stuff, right? So the same thing happens within the CPU itself, and we don't know how the deadlocks happen, right? Because everybody are given a certain amount of time to process, and during this time, if that particular web page is he is not able to get, then there may be other guys who are trying to vie for that CPU time, and during this process, certain threads can just get hung, and it gets hung, and then nobody is able to process. So that's why these deadlocks kind of happen. Yeah, it could be any reason. We really don't know how and what is the reason behind a lot of these deadlocks. Nginx. Okay, so Nginx, as I said, has become the new web server, which solved that, as I told you, the 10,000 connections per second problem. Okay. Now, so what is he asking here? So what is this Nginx? Okay. What about blocking calls? How to take care of single thread models? Can a web server handle 10K? How many requests can you serve? What is this 10CK issue? Okay. Now, as I told you, every server. When I say every server, every instance of a server can handle only one client. That's how it has been designed, and that's how the processing will also happen. Okay, so that means if you require 10,000 clients to connect, I should have 10,000 instances of the server running to handle these 10,000 requests. And as I said, we've always noticed when such high numbers of simultaneous connections are happening, there are deadlocks, memory is an issue, CPU becomes a constraint. So the whole issue of this scalability comes into picture. And it was during this time, right, the big guys, when I say the big five, Googles and Yahoos and LinkedIn, who wanted to come up with their highly scaling infrastructure, and they had this problem. It is at that time this Nginx was designed. So I told you how Nginx is designed. Nginx is designed in such a way. If you truly ask me, I can have just a single thread, and what I mean is a single server instance, and I can handle maybe 1,000, 2,000, or even probably 10K, depending upon how the CPU and memory are. So if you think it can handle 1,000 threads, then I just need to have 10 processors running to handle these 1,000 threads. Okay, so that is that big architectural difference between Nginx and your Apache. Now you may wonder then that in that case Nginx is the most powerful, and then why it is not used in every other application. There are other issues also if you design this way. When you design this way, integrating these two, we talked about server side, right? Server side application. Integrating this to server side application has not been great. So if you try to solve one thing, you get into another problem. So today I have seen many organizations, what they do is very funny. I mean, the architecture looks very funny, but it's a very interesting architecture. They use Nginx in the front end to act like a reverse proxy, and they do all the simultaneous connections. So you know that, right? They can handle any number of connections. Then they forward this to the backend Apache server to do the processing. So this way, we have tackled two issues. Apache server will help you to do all the processing. So they now act like an app server, right? You know the three-tier architecture, the web, the app, DB. Apache are more behaving like an app server, and Nginx is behaving more like a static server or your web server. Okay, basically it's nothing but a proxy, but it's behaving as if it is more like a static web server or a reverse proxy. Okay, so this way we have achieved both, and this is the architecture which has been followed in many places. Okay, any questions that okay, so any questions, any other questions that you're getting? So see the today what's happening, I mean, when we did not have so many servers, so many web servers earlier. Today, all the applications are going onto the web, right? Earlier time, all of us, when you want to connect to something, like if you take your desktop, or let's say connecting to your bank, Citibank always had a application, a front-end application to connect to your servers to do your transaction. But those days are gone, right? Now everybody is moving into the web, and as you see, the web is scaling, and web is becoming the entry point into an organization, either as just a blog, or either as a content information, or even to do some processing. Okay, so this infrastructure becomes the most. So how you design it depends on each individual. So I said one very popular architecture which is coming up is using this Nginx and Apache as your backend app server. Why? Nginx can handle these huge number of connections. And again, I go back to the same point which I keep repeating over and over about how these e-com sites, your Amazons and Snapdeals and you know the Facebook. How do you handle so many simultaneous connections? Is through these applications, and I know they use Nginx. Understand Nginx, but how does it improve? It improves number of simultaneous connections per server can handle. And you know that in front of your Nginx, you will normally have a load balancer, right? You will normally have a load balancer, who would then in turn handle all these Nginx requests as such, right? So that's how the whole architecture works around. Okay, so Nginx is a high performance HTTP server, and it is a solution to all of the above questions that were asked. Okay, and you know now why, how this whole architecture has been designed. Okay, okay, is designed for scalability, and that model which I talked about, right, where there is one server can handle that model is called your event driven model. So so can serve requests much quicker with lesser memory. Okay, that's the whole idea, and lesser memory, and also a lesser form of CPU processing. Nginx does not create new process for each web request. Okay, we saw that each worker can handle thousands of connections. Okay, and it does this asynchronously with one thread rather than using multiple threads. Nginx can serve static content quicker, but Apache includes the module need to work with the backend application, and so that's why I said Nginx is yeah, it can also behave like a proxy. It can also behave like a load balancer. Okay, and though you can actually integrate Nginx with other languages to serve general purpose processing also, but ideally not used. It's mainly used for connection aggregation and then dispersion to other web servers as such. Okay, so this is how an architecture would look like for Nginx. Now, these are integrations to your backend web server, app server, whatever that may be. And these workers are those individual threads which will handle those simultaneous connections. And yeah, you can see, I mean, this is one form of architecture people use, but there are mostly what happens is you are usually having Nginx as just a front-end reverse proxy, whereas all the other processing are normally done by powerful servers like Apache and all that. You may not find all these Nginx talking to cache and various other things. It may be talking directly to your to a web server, which in turn talks to the rest of the other applications. You would ideally, but you can also do this. There are some companies running in this format as well. Okay, it depends on your choice on how do you want to take it up. Okay, so we also have a demo for Nginx, and we will, as I said, we will be doing all of this in the next week. Okay, so as I said, so there's worker threads. So you can tune this. I mean, you can literally tune to have thousands of connections. Okay, that's the advantage. So to optimize, we need to tune up your worker process and worker connection. So the worker, this director is responsible for letting our virtual servers know how many workers to spawn once it becomes bound to an IP and a port. Generally, one worker process runs per core. Okay, that's the general architecture, and the number of cores can be checked by the following command. Okay, so it just tells you how many worker threads. So it is. I mean, though it is. Though they are telling like it, but this need not be a solution. Also, you may. But definitely, you want to map it to your cores. If there are 4 cores, I would ideally want 4 worker threads running, but you could also have 8 worker threads running. It's not going to really consume your CPU time. But as I said, Apache, if you have 1,000 users, we should have 1,000 threads, and that was actually literally having a squeeze on our hardware. Okay, so worker connections. This command tells the worker process how many people can simultaneously be served. By default, the value is so and so, and of course, it's not going to be 768. But generally, I told you about this, right? A browser can sometimes make 2 connections simultaneously. Okay, so you need to then make sure that the number of users should be twice that. And these are the general Unix commands to check what are your limits of opening files and things. So on a smaller machine of this number will probably read to 1024, and you can have all that configuration kept in your nginx.conf file. Okay, yeah, the number of clients that can be served be multiplied by the amount of core. So in this case, we can serve 1024 clients per second. But again, these are all parameters that we will do a stress test to find and understand, because it all depends on the application and the way you have designed it. And then we do an extensive test to come up to a conclusion. But these are general pointers to know where the things you can actually fine tune. Okay, so further again on the performance aspect of your Nginx, it shows you the number of processes, the number of connections, what kind of buffer size, and how what is the maximum body size that can be there, how large is your client header buffer going to be. So these are all the parameters we use by default as it is coming from the package, but you want to further fine tune this. It depends on how you want to look at your architecture and then doing your stress tests. Okay. Okay, so actually we are nearly reaching 11. So I probably maybe stop with Nginx. I have one more topic. I think that we will push it off to the next class. So buffer is nothing but caching. Is another important feature. So if buffer size are too low, then Nginx will have to write to your swap area. Okay, so that is definitely going to slow down. Huh? So client buffer, this handles the client buffer size, meaning any post. I told you about what post will do. Okay, client header, this handles the client header size. For all intent purposes, it's around 1K, and the body, the maximum allowed size for client requests. If it exceeds, then the client will split that. You'll get those errors. So again, all this depends on how you want to configure it, depending on your application. And large client buffers, the maximum number of size of buffers for large client that you can handle. Timeouts. Okay, so timeouts can also drastically improve your performance. So client body timeouts and header timeout directive responsible for this. The server will wait for a client body or client header to be sent after request. If neither is sent, the server will issue a thing. Okay, so keep alive timeout assigns a maximum time to keep the connection aligned with the client. And finally, the send timeout is established only when two operations of reading. If the time client out will not take anything, then Nginx will shut down. Okay, so these are the options that we can actually do. Okay, so today a lot of these companies do this compression, right? We'll have gzip enabled in your HTTP protocol itself. So anything that you send will actually be sent as compressed. But the problem here is when you decompress at the server side, if the server is not powerful enough to handle, then you will again have problem. This used to be popular a lot of time. People even use today. When you had, today if you take a look, all your index pages, if you just, Google doesn't have, you just go to Yahoo, the size of the index page, which was earlier, 30Ks and 100Ks and all that, today is nearly reaching 1 MB, right? If it's reaching 1 MB, that means you need to load this, and then what is the response? You need to load 1 MB file in less than that 5 seconds. Only then people will feel happy about the website itself. So if you want to do this, probably one of the techniques that you should be using is gzip, because anyway your clients are also today powerful enough to handle those kind of loads as such. Okay, so we have this option. And caching, yes, this everybody does, right? Everybody does some kind of caching. One of the best sites which I've seen, at least from an Indian point of view, has been the Flipkart. You see the way the Flipkart comes, you type in, you get everything loaded on your web page. That's because of the caching. They do great amount of caching, and their front-end servers, I know is Nginx, and they enable it through your Nginx to cache. Okay, so caching is the way to go forward, and along with caching, the other technology which is coming is your CDN, which is for to be closer to your location. So that's another way of getting. So CDN will invariably only do caching, and it is closer to where you are located. Okay, so that's how this whole thing works around. Logging, so everything needs to be logged. So your logging plays a very important role in your web environment. So logging helps you to tell how much, or you get all your analytics done through logging. So there are various ways to log. Some will do some will do a customized log, some will do default. So that depends on how do you want to use it. Okay, so I'm not going to touch load balancers for now. I want to kind of stop it at Nginx today. So load balancers I will start next week. That's next Saturday and Sunday, and we'll also follow up with labs. So that means I think just a couple of theory, and then everything we are getting into labs for these two modules. Okay, so I hope you kind of had a good understanding of a lot of these technologies, like your DNSs, your web servers. Now you're of course going to do your load balancers and things. We should have this full set of infrastructure and infrastructure software, what I call as infrastructure software, to build up this whole infrastructure. Any questions that you have, or we could then else wind up? Okay, so in that case, then we will wind up and catch up next week, continuing of this bit of a theory and then a lot of labs to make all this work, especially on the DNS. I know DNS is what everybody would look forward to, and we will get that labs going. Okay, so thank you everybody for coming in. So we'll catch up next week. Bye.